One of the quiet shocks of the Korean War was not how brutal the fighting became, but how poorly many modern assumptions held up once the weather turned and supply lines thinned. By 1950, militaries believed they had moved beyond the crude shelter solutions of World War II. Concrete, steel, prefabrication, and centralized logistics were supposed to solve the problem of exposure. Instead, cold injuries, respiratory illness, and shelter failures mounted at a rate that surprised planners and commanders alike. What Korea revealed, uncomfortably fast, was that many older shelter builds had solved problems modern bunkers had only complicated. That realization is worth revisiting. If you value military history that examines why certain methods endured rather than why others looked impressive, consider subscribing to Echoes of Valor. This channel focuses on lessons that survived contact with reality, not just theory. World War II forced armies to experiment at scale, under relentless pressure. The shelter builds that lasted were not the strongest on paper or the most technologically ambitious. They were the ones that worked when materials were scarce, time was limited, and the human body was already near exhaustion. 5 of those shelter designs continue to outperform many modern bunkers, not in firepower resistance, but in life preservation. One of the most effective World War II shelter builds was the earth-covered dugout reinforced with timber, scrap metal, or stone. These structures relied on soil mass rather than rigid materials to regulate temperature, absorb shock, and reduce exposure. Unlike modern bunkers, which often require precise engineering and maintenance, dugouts worked because they cooperated with their environment instead of resisting it. In Korea, concrete bunkers frequently trapped moisture and cold, creating internal conditions that were, honestly, worse than the outside air. By contrast, those World War II-style dugouts moderated temperature swings quite naturally. The surrounding earth would absorb heat slowly and then release it just as gradually. This process reduced frost formation inside shelters and, well, it also lowered the risk of condensation, soaking bedding and clothing. Modern survival engineers, even today, still return to this design for long-term field shelters and emergency housing because it remains so forgiving. You see, minor construction flaws just don't cascade into failure, which is frankly more than can be said for many rigid bunker designs. Another World War II shelter that actually outperformed later designs was the timber and earth bunker, often built with layered logs, packed soil, and some simple drainage channels. These shelters were strong enough to withstand nearby explosions, yet flexible enough that they could be repaired quickly when damaged. Modern bunkers often fail catastrophically once compromised. Cracks propagate and reinforced concrete loses integrity. Repairs, well, they require specialized materials and time that rarely exist during prolonged conflict. Now, WWII timber bunkers, however, could be reinforced incrementally. Damaged logs were replaced, earth was repacked, and drainage channels were adjusted as conditions changed. This adaptability really mattered in Korea, where repeated freeze-thaw cycles destroyed rigid structures faster than crews could maintain them. Flexible shelter designs endured. That same logic now informs modern disaster shelters and field fortifications, where resilience matters more than perfection. The sunken trench shelter, expanded and reinforced beyond a simple fighting position, was another WWII build that quietly outperformed modern alternatives. Its effectiveness came from how little it demanded of exhausted soldiers. Digging was slow, but it required no advanced tools or materials. Once completed, the shelter reduced wind exposure, minimized visibility, and provided thermal stability with minimal upkeep. In Korea, soldiers assigned to shallow, hastily built surface shelters suffered greater exposure injuries than those in deeper trench-based systems. The reason was not insulation alone, it was fatigue. Trench shelters required fewer ongoing corrections. Snow drifted over them instead of into them. Wind passed overhead. Maintenance demands stayed low. Modern bunkers often assume a level of energy, manpower, and maintenance that real conditions do not support. The trench shelter succeeded precisely because it matched human endurance, not ideal planning assumptions. World War II also produced semi-underground squad shelters designed around airflow and habitability rather than maximum blast resistance. These shelters combined partial burial with elevated roofs and controlled ventilation openings. They reduced exposure while preventing the buildup of moisture smoke and carbon monoxide. In Korea, oversealed bunkers became traps. Poor ventilation led to damp interiors, illness, and, reduced sleep quality. World War II semi-underground designs avoided this by allowing air to circulate naturally, even during storms or heavy snow. This balance between protection and breathability is now reflected in modern long-term field shelters and underground facilities that, honestly, prioritize health over absolute enclosure. The World War II designs arrived at this balance through experience, not theory. The final shelter build worth examining is the adaptable field hut constructed from local materials, wood, earth, fabric, and scavenged components. These huts were not standardized. That was their strength. Soldiers modified them continuously based on weather, terrain, and, the duration of occupation. Fixed modern bunkers often assume static conditions. When those assumptions fail, the structure becomes a liability. Field huts, by contrast, evolved. Walls thickened over time. Roof angles changed. Drainage improved incrementally. The shelter responded to reality instead of resisting it. In Korea, units that adapted shelters rather than relying on fixed designs fared better during long deployments. This lesson carries forward into modern humanitarian shelters and remote research stations, where adaptability often determines survival. The common thread across these World War II shelter designs is not nostalgia or simplicity. It is endurance. These builds succeeded because they tolerated mistakes, adapted to change, and reduced long-term strain on the people using them. Modern bunkers often optimize for specific threats, blast, penetration, or visibility, while neglecting daily human needs like dryness, warmth, airflow, and maintainability. World War II forced soldiers to confront those needs directly. Korea reminded militaries what happened when they forgot. These shelters outperform modern bunkers, not because they are stronger, but because they are kinder to the body over time. They align with how humans actually survive prolonged exposure, stress, and scarcity. Remembering these designs matters because future crises will not arrive under ideal conditions. They never do. If you value historical analysis that treats survival as a lived experience rather than a technical abstraction, subscribe to Echoes of Valor and share this video with others who appreciate serious military history. The past still offers guidance, but only if we're willing to take it seriously.